Now that we've decided to include an interaction in our model, let's be a little bit more formal about interpreting these coefficients. So again, we're going to be using the defaults in JUMP, so we can see the default here is that lakefront is 0 and not lakefront is 1. And our regression equation has an interaction term in it. We've got that x1 times x2 term, and then we can see in the output that we have coefficients for each of those terms. Okay, I'm going to write out the regression equation, and I think I'm going to keep 3 decimal places so that when I translate this back into dollars, right now it's in thousands of dollars, that I'll still have, whole numbers. So 0.220 times x1 minus 28.651 times x2 minus 0.136 times x3. Okay, so if we were to plug in Okay, so let's start with the lakefront houses. That's the easiest because that's the baseline group. So that's where you're going to plug in x2 equals 0. So when you plug in x2 equals 0, this part of the equation just goes away, right? So you're just left with the slope or the intercept and the slope that are given there. So for lakefront houses, it would just be 86.764, that's the intercept, plus 0.220 times x1, which is our size variable. Okay, so now let's take the ones that are not on the lakefront. So here you want to plug in x2 equals 1. So it starts off the same way, but you're going to have adjustments to this slope and intercept. So let's see, we've got minus 28.651. Obviously you're multiplying times 1, that doesn't really do anything. Minus 0.136. And I should really put, instead of putting x3 here, let me write it as x1, x2. That's a little bit more clear. Okay, so when I put in x2, I'm left with minus 0.136 times x1 and plugging in a 1 there. So basically I end up with 2 constants, and I put those 2 together to get my new intercept. Right, so I'm putting the constant terms together, and then I'm going to do the same thing with my slopes. So I'm putting these 2 terms together and then sort of factoring out the x1. So now I have a line for not lakefront houses that has a new intercept, 58.113, and it has a new slope, 0.084 times x1. So when you have an interaction term in the model, you not only get a different intercept, you also get a different slope. So we can basically be more precise with those descriptions that we gave earlier. So if I wanted to describe for the lakefront houses how changes based on size, I could say as size increases by 1 square foot, the price is predicted to increase by $220, right? So since it was originally given in thousands, I just moved my decimal place over. Okay, that's for houses that are on the lake. For houses that are not on the lake, starts the same way as size increases by 1 square foot. Price is predicted to increase, actually a lot less, predicted to increase by $84. So this is what we described earlier, that we have a flatter slope for the not lakefront houses than we do for the lakefront houses, but this is actually quantifying that change. So here we've done everything with indicator variables. What if you were to try to do the same model but with effect coding instead? So I'm just going to draw a little sketch of the graph. I'm trying to match it. So I had like, this is not lakefront, this is lakefront, and I have size and price. So remember, effect coding works by, instead of having a baseline group, comparing everything to like a middle group. So I'm kind of trying to go in the middle here, not just with the, the vertical location of the line, but also with the slope. Okay, because 0 is not showing up anywhere, right? -1 means not on the lake, 1 means on the lake. 0 has to be somewhere in between. So because this is an equivalent model, you should be able to get out the same prediction equations that we had before. So the one for lakefront and the one not for lakefront, based on these coefficients instead. So I want you to try that. Pause the video and use these coefficients and see if you can get back to those same prediction equations. So you should have one for lakefront, one for not lakefront. All right, so here's the formulas filled in. I'm not going to talk you through it while I actually write out all those numbers because that sounds extremely boring, but you can check your work and you can see that, besides maybe a tiny rounding issue, you should end up with the same prediction equations that you had for indicators. So you can see that it doesn't really make any difference which one you use. You're going to get the same predicted values either way, but you do have to be careful to make sure that the way you're interpreting your coefficients matches the type of coding that you used.